lesson 2.1 examples, some alternative examples. There are examples a lot like this that match the examples in your book. All right? Yeah. So you can actually look at those examples as well. They're very similar to these. They're just something that's not in your book, so you can see a human do it. All right, so what we need to do, we've got this stem plot here. And it represents a number of wins for 30-meter baseball teams in 2012. And then we've got this, this key. Remember, this one's really well done because it has a key. If yours doesn't have a key, it's not right. So what are we going to do? We're going to find the percentiles for the following teams. Well, I know that there are 30 teams, right? 30 total teams. So the Minnesota Twins won 66 games. So I'm going to assume that that's our Minnesota Twins there. Or, as they said, Minnesota. Minnesota, don't you know? Up there, it gets mighty cold in the winters. Right. So how many were below? How many were below that? We got 1, 2, 3. Only 3 teams. That sucks for them. But anyways, only 3 teams had less wins. Right? Not bad. 61 wins. That's a lot of wins. Anyhow. 98. Yeah, 98 is a lot. If you play 200 games, you're bound to catch a W every once in a while, right? Hopefully, unless you're awful. So then for A, we're looking at, we got 1, 2, 3 out of 30, which is some sort of percentage. 3 divided by 30. Exactly. Sorry, exactly. 1 or 10%. Is that all they want? They want me to find the percentiles? So I got to be careful whenever I'm answering these questions, right? That I answer them in context. In this case, was there some context? Not really. They just wanted a number, right? Sometimes I'll have to write a little bit more to make sure that I put it in context. But they just said, find the percentile. Or I could say 10. I could also say 10. So there are 3 below. So they were the 4th highest, right? Which puts them at the 10%. So then for B. Yeah, you know what I'm saying? Don't include the one that you're doing. That's the most, I was saying yesterday, that's the most common mistake that occurs. Oakley dokley. That's my internet Flanders. There we go. Okay, so. The Washington Nationals won 98 games. I'm going to assume that they're the best. So then I'm going to say that would be the... Well, okay, how many are below them? 99? Everyone else. Everyone else? Oh, and we are going to approximate, sorry. 0.967, or I'm actually going to say 97. There will be, yeah, you would need more data points to get 99%. And then, do I need to do the Texas Rangers and Baltimore Orioles? Sure.
Oreos.
Did I say Oreos? I said Orioles. Did I not, or no?
I saw you said Oreos.
Okay.
I can't hear the L. So.
Okay. So 93. I'll erase this. 93. These two. We'll call them a tie, right? So, okay, let's go. 30 minus 8, so 32. So I went like this. I said 1, 2, 3, 4, 5, 6, 7, 8, right? If I want the number below, I'll subtract that from 30. And that'll give me 32. Cool?
Wait, wouldn't that be 22?
Oh, you know. 32 out of 30 people don't have problems with math. So,
Yeah.
so there we go. Thanks.
Yeah.
I appreciate that. I was wondering why people were looking at me so confused. I was like, that's not that hard.
Yeah, it's 32 out of 30 people.
Oh, sorry. Alright. So, what is that? That we calculate a percentage? That is approximately 0.733, or we'll call it the 73rd percentile. I've also chosen these problems because they're a lot like that homework assignment that I gave you, especially this one. There's a few ogives in here, your cumulative relative frequency, and you have to watch me because I have a tendency to switch the two. I call it relative cumulative frequency a lot. And that's cumulative relative frequency. It's okay, you know what it is. So, all right. So here we go. We've got a graph for the distribution of median household incomes for the 50 states, right? And what we're able to get is a percentile, right? So if we're looking at this column, right, tells you how frequently each data point occurs. This gives you a percentage of occurrences of each of those data points. This right here gives you a ranking of those data points, right? So, in other words, there are 14 data points that are from 45 to 50, right? And that represents the top 25 of your total data points. That's how you read that, right? In which case, you're able to get a percentile, say 25, or a percentage. All right. What's important is the questions that you're being asked here. At what percentile is California with a median household income of $57,445? All right. So, California. I have a feeling that's not an accurate number. Because it's a lot of money to live there, and therefore you get paid a lot. I hope. All right. So we're gonna look at we're gonna estimate what's 57, I guess, something like that. 57 point somewhere around right here. Try to make it as straight a line as I can. Yes, I think it's okay. I might flip it over. It might actually be, yeah, it might actually be that, right? So I think that's what they're trying to get. Perhaps. And so we're going to match this up to our vertical axis. And that should give us an estimate of the percentile. 75. I think that maybe 75 is more meaningful. Why is that? So we would say, what percentile we're going to say the 75th percentile. And why is the 75th percentile meaningful? In terms of a 5-number summary, which number is that? It's quartile 3, right? So it's also, you could say it's also Q3. Cool. So you could get a 5-number summary from a cumulative relative frequency graph. And hey, let's estimate and interpret the first quartile of this distribution. All right. Well, how will we find quartile 1? We'll go to 25, right? So somewhere around here, yeah. And then I guess we'll drop down. We can estimate that we're going to say quartile 1 is approximately 45,000. And if we're going to interpret that in context, we would say that 25% of household incomes in California are below 45,000. An interpretation of that in context. I'm going to write that down. So we would say 25%, or approximately, my bad. In statistics, we talk a lot like your parents talk when you ask them to do something and they really don't want you to go, or they're thinking about it still, right? They don't give you a definite answer. They're like, maybe, right? Or maybe maybe that's just me. All right? They're like, maybe, let me talk to your dad and we'll get back to you on that, right? So that's the kind of thing. I don't want to say for sure that, right? I can't say for sure that that's what's really true, because it's probably not. It's probably a little bit different. So I'm going to say approximately 25% instead of saying 25%, because that might not be true. But definitely we've made a good approximation from this graph. So approximately 25% of household incomes. And 45,000. Some of them. All right, so now let's talk about z-scores. Remember, a z-score we called a standardized value, and we had a fantastic formula, right, that said that our z-score, or our standardized value, tells us a position above or below the mean, a position of any x value, I should say, right, is going to be whatever that x value is, minus the mean, divided by the standard deviation for S of x. Remember, we call mean x bar. We're calling that symbol x bar, and we're calling the denominator symbol S of x. So we can use this and interpret these z-scores. So I don't know why it's so baseball-y, but if you like baseball, that's great. Okay. We got 95 wins, so that's my x value, 95. They've told me that we have a mean number of wins of 81. And then my standard deviation is 11.9. We'll plug that into our handy-dandy calculating machine. And we get approximately 1.176. All right. And we were asked to find and interpret. So I just did this part, right? If I was being told to find and interpret, I have not finished the problem. I need to interpret. So in context, right? So we always want to, you know, be specific and write in weird ways. Right, so we're gonna be specific. We're gonna be specific. So in context, we would say the number of wins for the, I'm gonna just say New York Yankees is 1.176 standard deviations sorry about the writing, deviations above, it's positive, above yes, I'll post this. I'll get it up today. And you can go to my YouTube channel if you want to subscribe.
Do you really have
Huh?
Do you really have YouTube channel?
Yeah.
Comment down below.
Yeah, you can comment down below.
What's
There's a merch link.
Yeah. Comments to the giveaway.
What's your YouTube channel called?
You just look for Patrick the Dorman.
Danger Dorman?
It's not Danger Dorman. It's my other one that has mountain bike and snowboard. Oh, no snowboard videos, but a bunch of mountain bike videos on there.
Danger Dorman.
Found it. That's a big one. Robot scrap.
Okay, here we go. All right, so now let's do B. The New York Mets had 74 wins. So 74 minus our mean, 81, divided by our standard deviation, 11.9, which is going to be approximately, I'm going to guess that's not going to be a whole number, 74 minus 81 divided by 11.9 turns out to be negative, and here we go. We get to interpret what it means when our z-score is negative. So we would say the number of wins for the Mets is 0.588 standard deviations below the mean. just real quick, so it's not hanging out in space, and don't get too hung up on this right now, but I just have the hardest time talking about standard deviations above and below mean without showing you what a normal distribution looks like and kind of pointing out what a standardized version of that is. And in so doing, I can also talk to you about what counts as an extreme value for a z-score. So, right here, this looks like an approximately normal distribution. I'm going to say that it is a perfectly normal distribution, not because I've drawn it like that, just because I've said it. So, mathematics often is good reasoning from bad drawing, so here I am. So let's call this x bar in this case. If this is indeed a normal distribution, I should use the symbol mu for mean, but I don't want to give you guys too much. Right? So what you have here is 1, 2, 3, and these are each standard deviations, right? 1 standard deviation from the mean, 2 standard deviations from the mean, and 3 standard deviations. What's going to happen is I put these strategically in inflection points on this graph. It turns out that you'll find your first, second, and third standard deviations on the inflection points in the graph. Not something you need to know right now. I just want to show you that if this is your mean, right, 2 standard deviations from the mean is fairly far, right? I'm sorry, that's negative. Negative. Sorry. 3 standard deviations from the mean is a lot. It's a lot. It means that whatever x value you plugged in, if you got a 3 or greater, if you got a 5, something crazy like that, what you have is a very, very unusual value, right? Or an extreme value, possibly an outlier. You'd have to check. You'd have to use your 1.5 times IQR rule to find out. So I just want to give you a little picture of that and tell you what extreme values look like as well. All right. Hey. Single season. There's a lot of writing there. You can read it. So what's going on? We're saying that it might be easier to get home runs in a certain era than it was in another era, right? So it might be, and man, I was a little shook when they mentioned performance-enhancing drugs in that flip theory. I mean, it might be the case that, like in 2001, all these guys that were super doped up and just cracking bats, getting crazy and just hitting home runs, right? So there were probably more home runs being scored during that era than maybe there were during Babe Ruth's era, right? Where they, prepped for games by smoking cigarettes. They did. My friend has a picture of the Tour de France, like back in the 1920s, and they would get one cigarette lit and be riding, smoking a cigarette, and then they would, use that cigarette to light everyone else's cigarettes while they were doing the Tour de France. Tour de France? I don't know. I can't remember. I have to say it wrong. So times have changed, exactly, right? Times have changed. So you would want to say comparatively, how did they do, right? How did they do compared to everyone else in the league at that point in time? It might not be that great. If tons of people are hitting home runs, then it's not that big of a deal to hit 73. But if it was harder to hit a home run in 1927 when Babe Ruth was doing it, then maybe that's a better measure, right? So let's look at this. So we're going to go Z sub B, Babe Ruth. Oh, we'll have to do BB for Grey Bonds. So let's look at a Z-score. He did 60 home runs, minus our mean of 7.2. And then our standard deviation was 9.7. So let's get Babe Ruth's z-score there. 7.2 divided by 9.7. So that was approximately 5.443 standard deviation above the mean. And then we'll go Z sub Martin. That's 61 minus 18.8. That is a large mean compared to the other one, divided by 13.4. So, will someone calculate that for me while I write down the other stuff? Z sub Mark McGuire, I guess we'll do. So, 70 minus 20.7 divided by 12.7. Did anyone get that calculation for Roger Maris? 3.746. You said 2 was that, right? Yeah. Anybody get Z sub Mark McGuire? 23 minus 21.4 divided by 13.2. Let's give them the approximate as well. Anybody get Mark McGuire? 3.882. Yeah. Okay, and how about Barry Bonds? 3.99.
Yeah, it's just 909.
9099999. Are we sure it repeats forever?
No, it's just 909.
Oh. So it looks like comparatively, Babe Ruth did better. Can anybody else? Does anyone know any of Babe Ruth's nicknames? Huh? The Sultan of Swat? Sandlot. Okay, thank you. I was making a Sandlot reference. So comparatively, it looks like Babe Ruth really is the Sultan of Swat, right? Okay, because that is a very unusual. That is a super high z-score. And all right, on your calculators, you guys have this. I just wanted to play with it a little bit. Perhaps, let's determine that right now. So when we come back, we will transform this test data and look at how it changes our measures of centers and our measures of spread. If we transform it by adding, subtracting, multiplying, or multiplying by a fraction.
When is the homework?